Assessment 2 reframes the problem and persuades change. This is presented by Group 7, Emily Aboud, Salam Al-Jazini, and Cameron Blackladder.
The topic of this presentation is reframing the problem and persuading change. The elements of the Paramatha Engineering and Innovation Hub do not directly target the user's needs, and thus are not used as effectively as initially believed to be used. This is because the BEIH building had begun construction in 2019, prior to the pandemic, where social distancing and the need for constant sanitation of shared surfaces became imperative to community safety, thereby reshaping the user's needs. The Hazza Street building has a range of different unique areas and elements throughout the building. The stairway leading to the makerspace area, the wired wall on level 1 and 2, as well as the smart elevators can be very unsafe because they can easily spread different diseases and inflict different danger for the users.
The main research question being, has the Parramatta Engineering and Innovation Hub become more hazardous as a result of the building's advanced design elements that were user-oriented prior to the pandemic? This investigation exclusively looks at the smart elevators, wired walls, and the makerspace staircase. Therefore, my subsidiary question, which looks at the smart elevators, considers whether or not they allow for user satisfaction with respect to its flexibility to change.
Problem statement. What can be changed to make this makerspace staircase safer for everyday users?
My subsidiary a problem statement for wired wall is what are the possible measures to manage and remove the hazardous potential of the wired wall.
The main research question investigated how the PEIH building has become more hazardous as a result of the building's advanced design elements that were user-oriented prior to the pandemic. Therefore, previous data collected in A1 was analyzed, as the investigation has been slightly reframed to suit a more analytical evaluation. Furthermore, the evaluation was supported by additional findings of more targeted primary and secondary data. This included first-hand observations, informal interviews, mirror mappings, as well as readings from newspaper excerpts, trade articles, and scholarly journal articles. The empathy maps recorded on Miro found that users are frustrated by the elevator's pre-programmable nature that limits their ability to make changes, in addition to the concerns raised about the risk of transmission with the shared smart pads. This unfavored view on the smart elevators has been reflected by the interview, which sampled 25 users of the PEIH building and found 75% had logistical concerns and 84% desired a more personalized smart elevator system. On the other hand, through the concept model diagrams, it has deduced that students and faculty are adequately satisfied as they value the elevator's maximized efficiency as it encourages higher levels of productivity.
The collected data showed that the users are unaware of the potential hazard that the wired wall have, as most users did not mention the wired wall as a hazardous potential as seen in figure 16. Moreover, if we looked at figure 15, we can see that 60% of the users are indifferent to the potential hazard, which is a hazardous sign. The data showed that the design of the wall is appealing to most of the survey participants if we look at figure 11. Nevertheless, the participant users gave the potential hazard of the wired wall 3 out of 5 in the survey conducted. The participants, the users, have suggested some possible solutions for this problem, and most of the responses maintain the same design concept.
A large percentage of users do not like the look and the feeling of the staircase. More people dislike the stairs than the amount of people that do. Reasoning behind this was mainly due to the shape of the stairs. Other reasons were brought up were the spacing and the size of each individual step and the minimal amount of handrails. The data collected can identify that the regular users of the staircase aren't happy with them. Now, since gaining this information, it should be easier to identify the issue that should be fixed and change it to make it more user-friendly.
Through the foresight strategy, it has affirmed the need for future amendments to the smart elevators system. It highlighted the possibility of installing weight sensors to ensure the maximum occupancy abides by social distance protocol. Furthermore, it discusses the concept of regular sanitization of the shared screen by maintenance staff hourly on weekdays. Moreover, the smart elevators could alter its internal design to include an electronic pad, which could reconfirm the user's route to allow for last-minute changes upon entry. This ability to reconfirm route could similarly be applied to the external keypads.
Changing the user's behaviors to remove the hazardous potential is not effective. Users are indifferent of the potential hazard, therefore no responses will be made. The best solution is to modify and change the design of the wired wall without changing the conceptual design, especially it's contributing positively to the studying environment. The possible solutions that were suggested are installing a glass wall mesh or installing a kickboard. The recommendation is to assess the practicality overall contribution of installing a glass wall. Installing mesh and kickboard should be examined more and a prototype should be made.
In conclusion, changing the staircase design and adding another set of stairs on the opposite side of the already existing one will make the area a lot safer and easier for regular day users. The implementation of another side of handrails would also help users use the staircase. Completing these changes will mean for different building and design will need to be placed to complete these changes. How difficult will it be to complete these changes necessary?